Good morning, student. Today we are going to learn about classification of spread spectrum. After the completion of today's session, you are able to define spread spectrum, classify spread spectrum, and explain operation of different types of spread spectrum. So, spread spectrum is type of signal modulation in which the signal frequency is spread over a very large bandwidth signal. The large bandwidth signal is known as pseudo noise sequence or PN code, or we can say also chipping code. So this one is the spread spectrum signal and this one is the data signal. So this data signal is multiplied throughout this spread spectrum. Okay. The main advantage of spread spectrum communication technique is to prevent interference, whether it is intentional or unintentional. An intruder with no official access is not able to crack them. Hence, this technique were used initially for military purposes. Spread spectrum was also known as noise modulation. This was because the spread spectrum signals look like a noise to an ordinary FM AM receivers due to spreading of signals over a large bandwidth. Okay? Then classification. There are three types of spread spectrum. So first one is the frequency hopped spread spectrum. In a frequency hopping spread spectrum system, a transmitter hops between the available frequencies according to a predefined program. Next one is the direct sequence spread spectrum. So direct sequence spread spectrum most widely used system. Okay. This process is achieved by multiplying a radio frequency carrier with a pseudo noise code or PN code. The PN code is a binary signal which is produced at a higher frequency than the data signal to be transmitted. Last one is the time hopping spread spectrum. In time hopping is one of the technique of spread spectrum technology. In this technique, a pseudo random code sequence determines the on and off condition of the carrier. Okay. Next is the direct sequence spread spectrum. So in direct sequence spread spectrum, it is a technique which extends bandwidth of input signal. Here input can be modulated by PSK, QPSK or QAM. It is a digital spread spectrum. In DSSS, the baseband signals are called bits. Okay. The baseband signal called as bits and the code bits, that is PN code bits, are called chips. The baseband signal bandwidth is multiplied several times by the spreading signal. Okay, means this one is the data signal and this code generator gives the code bits or PN sequence. The spreading signal sequence is unique for a transmitter, and the same chip sequence is used at the receiver to reconstruct the signal. And we generally multiply the data sequence and the PN code sequence by using different technique, means XOR, XNOR, and this type of operations are used to multiply them. Okay, here we use XOR operation. in the DSSS transmitter, a code generator is a pseudo-random generator that generates a known pseudo-noise code sequence. The code has finite length and repeats periodically. In this figure, here, in this figure, each data bit is coded with each 8 chips. Okay, here 8 chips. Higher the number of chips per bit, higher will be the processing gain. So here we can see this one is the data bits and this one is the pseudo random code, and here we use the XOR operation. So here 8 divisions are present. So when the data bit is 1 for all the 8 code sequence, then 1 1 means 0, 1 0 means 1, 1 0 means 1. As for the XOR truth table, we get our output. So each bit of data sequence multiplied with the whole chip sequence repeatedly. That is the procedure. And when it is received by the receiver must have the same PN code sequence, and it again do the XOR operation with that received signal and the PN code to get the original sequence that is transmitted from the transmitter section. Okay, so here we can see in the transmitter section, this one is the transmitter section, another frequency multiplier is used. This is used for op conversion of the signal. Okay, and here this one is the receiver section. In the receiver section, this part is similar as the transmitter section. Then we use the filter circuits for filtering of the signal, and again here we use a multiplier for down conversion of the signal. Okay, here it is used as a down converter, and at the output of the low pass filter we get the demodulated signal or original signal. Okay, so the receiver section consists of a PN generator that feeds the matching chip sequence or PN sequence as used in transmitter to an XOR gate to reproduce the original bit sequence. The PN generator is driven by an error signal. This feedback loop. This one is the error signal from the output of the low pass filter. An error voltage at the output of the low pass filter provides necessary correction to the PN generator. Okay, next is the frequency hopped spread spectrum. So in frequency hopped spread spectrum, users are made to change the frequencies from one to another in a specified time interval, hence called as frequency hopping. The frequency of the data are hopped from one to another in order to provide a secure transmission. The amount of time spent on each frequency hop is called as dwell time. Okay, dwell time. So see here, this one is the diagram, consists of baseband modulator, then PN generator and frequency synthesizer. The original signal present in the form of FSK. Using this baseband modulator, here we get a FSK signal. Okay, then as per the PN generator code, the carrier signal is selected. So for example, if we take a 3-bit code, okay, then we have input combination of 2 to the power 3, means total combination is 8, means 0 0 0 to 1 1 1. So if 0 0 0 is given, then F1, carrier F1 is selected. Like this, for 8 combination, F1, F2, F3, F4, F5, F6 up to F8, means if PN generator give a sequence 111, then F8 carrier is selected. So as per the PN code, the carrier is changing. So we can say as we change the code of the carrier frequency will change. Okay. So changing frequency with respect to time also we can say. There are effective digital modulation methods like PSK, QAM and PAM. But these methods are not effective for coherent detection. So the FHSS uses FSK for effective coherent detection. Okay. So here as per the code, the frequency synthesizer select the carrier signal and given to this multiplier. To this multiplier, the modulated signal and the given carrier from the frequency synthesizer are multiplied and transmitted. So there are two types of hopping are present, that is slow hopping and fast hopping. When the beat period is greater than the chip period, then that is known as fast hopping, and when the chip period is greater than beat period, then that is known as slow hopping. We always prefer fast hopping. Okay. So simply we discuss about the transmitter and receiver section. So we can say mainly this frequency synthesizer is driven by a PN generator, and a PN generator may be built internal to the synthesizer. The synthesizer hopping different frequencies at different point of time, and at the receiver end the same principle works, that is used in transmitter section. So a FHSS receiver consists of a down converter followed by a demodulator. A synthesizer driven by a matching PN generator is used to down convert the received signal. So this is all about FHSS. So this is all for today's class. Thank you.